All right. I will apologize right now. I know there's a lot of people that do VB. I was cursed by being a computer engineering major at college, and they made me do assembly language and C, and so I like the squiggly braces. So all the code I show today will be C#, but everything I do here is certainly valid for VB. So the talk, and who I am, and all that fun stuff. This is kind of, WPF for developers. Rob went through some kind of basic introduction of kind of the stuff you can do in XAML. What I want to talk about here today is this idea that developers still matter. As powerful as all the stuff we can do in XAML, all the things you can do in Blend, all the things you can do in markup, as cool as all those things are, I want to talk today about how the developer, how the guy sitting in front of the compiler, sitting in front of Visual Studio can add value. So my name is Kevin Moore. I'm a lead program manager at Microsoft on the WPF team. There's my blog, and let's get rolling. Oh, and before you guys fill out your evaluation, since I've heard this before, I've had no stimulants today. I swear. This is all completely natural excitement. So let's talk about XAML. We hear a lot about XAML. We've seen a lot of XAML this week. Why do we think XAML is cool? I think it's really 4 things. First is that it's XML. My favorite joke about XML is that, what was it? XML is like violence. If it's not doing the trick, you're clearly not using enough of it. In some cases, I think that's true. I think XML is kind of used, to solve every problem. In this case, I think it actually adds a lot of value. For the second bullet, it's interop friendly. There's been tools around for XML for 15 years. It's 1,000 times easier to generate via tools than, say, code, right? And so it makes it inherently toolable. Which gets to the final point, this notion that's designer friendly. Because it's easy to tool, because it's easy to make tools for, designers can finally plug in to a UI system if it's based around XAML and XML. So where does code really add value? Again, I think it's 4 things. First is this notion that you can leverage .NET. If you think about the universe of things that Microsoft produces in the .NET kind of sphere of stuff, you have our server products, ADO to access the backend, Windows Workflow, Windows Communication Foundation for doing networking, all the access to the hardware, access to devices. This whole world of stuff that exists in .NET, and that's just the stuff that Microsoft ships. There's, yet again, a whole other ecosystem of things around .NET the community provides. And so the guy that writes code can leverage all that infrastructure. Which gets to the second point, right? It actually allows you to bridge business rules. Most people that actually implement, your second tier, your business logic, write that in code, right? If you're writing, store procedures on your SQL server, you might be writing those in managed code. So that's kind of, when you talk about plumbing, right? .NET's really valuable there. What's that? I fell down. Can you guys even hear me? I'm talking loud. I'm sorry. Is that better? Wow. Could you hear everything I said to that point? Okay? All right. I'm trying to. Not going to be quiet. The third thing is this notion that you have power over the visuals. And that idea is because we're managed infrastructure, right? Because everything in WPF, in the end of the day, ends up being instantiating a type, setting properties. Because you're writing code, you have access to all the plumbing. And we'll show towards the end of my talk why that really enables an amazing set of scenarios that you couldn't imagine doing in a designer. And the fourth thing, the final thing, is this notion of enabling the designer. So what does that really mean? I kind of think of it as this kind of proof I could imagine doing in geometry, right? Like designers use tools, right? Tools manipulate XAML. XAML instantiates types. Actually, Rob talked about this, right? You have the button tag, the angle bracket button tag, and you have the button class. One-to-one correspondence, markup equals OM. So when you do a button tag, you're newing up a button. When you set the width property, in XAML, width equals parentheses, 25, we walk up to the button and set the property, the CLR property. And so, there's this mashup between what XAML defines and what the code defines. And so since types are defined in code, basically nothing is available to a designer at all unless it's implemented in code. And so you can think of this in kind of a malicious way in that the developer kind of is the guy who restricts what the designer really can accomplish. Actually, I take it as a positive thing. This is an idea that XAML plus code equals cool clip art. No, love. And what I want to talk about a lot today is, as a developer, approaching WPF, how do you write your code so that you can really enable the person doing design? Now, I'm not naive as to think that a lot of people, there's just kind of the guys that do the code and the guys that do the design, and there's this big firewall. I think a lot of us in the room will probably play both parts, right? And you've listened to other talks this week. people talk about this idea of the integrator, the guy who kind of sits in the middle. So even if you're the person that kind of does it all, even thinking about these kind of philosophies I'll discuss will make your development easier. If you factor things out well so that you have a clean separation between code and XAML, you'll have, you'll build more flexible components, more flexible applications, cleaner applications. And so, even though I'm talking about a lot what the designer does and what the developer does, it can be one person, right? All these things certainly apply. And so I want to talk about developer kind of in 3 contexts in this talk. It's developer as plumber, developer as widget author, and developer as groundbreaker. Let's start with the plumber. So this idea that, the designer is the pixel pusher, because developers always have a very, and the designers wear berets and they have goatees, right? We have this very kind of bad notion of what a designer does. Really what you want to think about is, every time that you have kind of spaghetti between the XAML and the code, you're losing flexibility, right? Every time you implement an event handler, and that's necessary and good, you might have to do that, but you're making this tie-in, right? Oh no, there's a name now in XAML that refers to a method, a private method in code, and that gets a little fragile. And so what I want to talk about is places where if you build your data layers correctly, you really get a lot of flexibility. And so basically it becomes the designer asking for properties and things, and really enabling stuff in the UI. So we'll get to some samples as soon as I go through this set of things. And so really when you think about developers, plumber, and WPF, it's really kind of 3 areas. This notion of singular binding, list binding, and commanding. So singular binding is I have one class, one property, and I want to represent it in the UI. So what I want to talk about is kind of the split between what the developer thinks about, what you think about in code, and what you think about in markup, in XAML, in the design tool. So for single binding, it's really simple. It's public properties, public CLR properties. And so you do a getter and a setter. That's it. And if you don't want things to be accessible via your designer, you just do get and no set, right? And so this actually becomes the way you can kind of restrict, please don't come set me, and this is, an important part of the business logic, and so you just do a public setter, right? The other important thing is this simple interface that's been around since the first release of .NET, notify property change. This is the way your business object can notify and say, hey, the count is incremented, the first name is changed, something like that. And so again, in your business layer, if you're implementing notify property change, we can actually reflect that, and bindings will update things in the UI, and you can trigger off those changes in the UI if you implement the interface. So in the business logic layer, that's really about it. On the UI layer, in the design, in the markup, those are the concepts you think about. A data template we'll get into, and this is the idea that I can take a data object and actually generate a tree that represents that object visually. And so the example I always give is button, right, in WinForms. Who's WinForms developer done WinForms? A little? Oh, a lot of you guys. Okay, good. Right, so button has the text property, right, and we put text in the button, right? And someone came along and well, sometimes people want images in a button. It's okay, we'll give you an image property, right? So I have text and image, great. Well, now I want to position those things. So let's do image alignment, right? And that's an enum with 4 values. I can do that, I can do that, I can do that, I can do that. And that's it. And any more than that, if you want to do things at an angle, if you want a second image, you want a second piece of text, boom, you're in code, right? And then it's inflexible, it's tough. This whole issue about, the designer wants it to look a certain way, and the developer really doesn't want to do all the nuanced work to make it work that way. It's really inflexible. So fundamentally, we have this notion in WPF of a content model. And the content model says you can take a button and put whatever you want in it. So you can put in a 3D object, you can put in video, you can put in a grid and put in 15 other elements. Not that necessarily would say you should do that, but you could do it. The other thing is, if you look at the content property, it's not even a visual, it's an object. And so you can actually put in arbitrary data. You can put a customer in a button. You can put any other business object in a button. And then what you use is use a data template to define what the visual for that customer is. And what you use is binding and data trigger to represent those things. And so you set a data template, say for a customer, you put in text blocks that represent the first name, the last name, the count, and you put an image element in that represents the picture, and then you use binding to say, okay, I bind the first name in the text block to the text, last name, etc. And then data trigger actually allows you to trigger off changes in the data to change the UI. So that's single binding. List binding, same kind of magic, right? We have a set of interfaces that are known, IEnumerable, iList. I'd actually really opt people towards iList. It's much more efficient, so just keep that in mind. There's actually a little trick here. If you implement iList of t on a class, it'll implement IEnumerable for you, but actually will not implement iList, like the non-generic iList. So be really careful when you implement iList of t that you actually, explicitly implement iList, because we get some issues there. The second interface is iNotify collection change. So this is actually the analog iNotify property change to let you know when your collection has changed. An item has been added, removed, moved. And we actually wrap all this functionality up for you in a class we call observable collection of t. And so use that collection, and if you change your collections, the UI will reflect those changes. And on the WPF side, we have a control, items control. And there's a set of subclasses to items control: tree view, list box, list view, combo box. You actually can use list items control directly. And what this does is allow you to bind to a collection. And what it'll do is it'll actually generate UI items for every item in that collection. Now, there's two cool things there. First is, when it generates those items, where does it put that? In a panel. And by default, if you think about a list box or a list view, that panel is a stack panel, right? Just vertically. But you can go into that panel, that stack panel, and do orientation equals horizontal, and now things go horizontally. You can put in a wrap panel, and now items will wrap in the list box. The semantics all stay the same. But because items control is flexible with a panel that used to display things, you get a very flexible UI. The other interesting thing is, when it generates these containers, they're content controls, just like buttons are content control. And so now when you do the data template for your list of customers, you're now just thinking in terms of those single binding concepts for items control. And the third thing is this notion of commanding. So systems before have had a model for how you display data and visualize data, do binding, et cetera. What often you kind of fall off a cliff is this notion when you want to do interactivity. Right? When you want to actually change the data in some way. And that's where you end up implementing click handlers. And those can be very inflexible for all the reasons I kind of listed before. Commanding is actually a model where you can actually basically provide methods and a way to bind methods to controls. And so all you can do is implement the iCommand interface. And what's cool about iCommand is not only does it let you basically implement a method that takes a parameter, there's actually an event on it to say, can I execute this now? And if you disable the command, the UI element associated with that command will also disable. And we'll show that in a bit too. So iCommand is the kind of the data object level interface you think about. And then in the UI level, we have a set of controls that implement iCommand source. And so button, menu, hyperlink, and you can build your own. So let's take some time now and look through some demos, kind of thinking about developer as a plumber. So let's actually start by running this. This is the bag of tricks that a lot of people have heard about. And so everything I'm showing today is all from the bag of tricks, and I will show you where to get the bag of tricks when we're done today. So let's start with a folder picker. So very simple, tree view bound, and I can click in and click on stuff, check. So let's imagine how we'd write this in WinForms, since there's a lot of WinForms developers in the room, right? Well, what do we do? Well, we'd have a for loop on the window load. We'd go find the tree view in our UI. We'd do the for loop and generate and go generate new tree view item, new tree view item, new tree view item. We'd recurse down every directory, create new tree view items. That's really bad for a lot of reasons. One is we actually generate a node for every item in our data, right? So if you have a huge folder structure, we go create every node. Now, we could be more efficient, right? You could say, well, let's actually handle the event clicker and command and populate kind of, on preview. Expand. Well, that's even worse, right? Because now we have even tighter kind of binding between our UI layer and our data layer. The second thing is we're really limited by what tree view offers, right? We have an icon property and a checkbox property, and that's about it. And then obviously we'd have to handle the click event on the checkbox, listen for the checkbox, and then go repopulate our selection on the right here, right? That's actually not how we do things in WPF. So what we have in WPF, actually I created a data object. And so if you think, let's step back a second, directory info, right? System.io.directoryinfo. This is the class that lets you look through directories and files on the system. That's a very bad example of a data layer thing you'd use in WPF. Because actually, if you want to get directories out of directory info, you need to call a method. And so what we talked about before is you need public properties to do that. And so what we do here is I actually basically just build a data layer that reflects against directory info and actually exposes public properties instead of methods. That's all I really do. And so if you look here, I have a derives collection, which exposes this class I created, selectable directory. And then I expose another collection of things called the selected directories, kind of for everything in my system, all the selected directories. And you notice for this object, I implement notify property change. Okay? Pretty simple. So let's look at selectable directory. It's right here. And so again, you'll notice this recursive pattern. I just have the selected directories and subdirectories, again, expose as collections on this class. And then I have a set of public properties. So I have name, path, is selected. Now, is selected is interesting, actually, if you look at it. It is a getter and a setter. And so I can actually set this property via UI. And we'll go to look at the UI in a minute. We'll see how I actually set a binding up to do a two-way binding with the checkbox. And so when I check the checkbox, I set the isSelected property. In the data layer, I update the selected directories property. This actually bubbles up the tree using identify property change in my data layer all the way up to this, and selected directories gets updated on my top level item. And so selection is actually all managed in my data layer. There's actually a set of other things here, very simple properties, child selection and isDrive. So child selection actually exposes out an enum saying, what's the story of your children? Are they all selected, or some of them selected, or none of them selected? And then I have another property here, which is isDrive. It's nice to have a homogeneous data model, this kind of the selectable directory class, but you'd want to use it for a drive as well, but maybe you want to change the icon for what a drive looks like. And so let's just make it in the data layer and make it a bool so you can easily see are we talking about a drive or folder. So now that I have a data model that's implements identify property change, public properties, let's see how you actually visualize it in WPF. So here I create a hierarchical data template. So forget the hierarchy for a second. Let's talk about the data template. What do I have? I define a stack panel, a UI, horizontal orientation. Inside this, I put a checkbox. And actually, if you look at tree view in WPF, you'll notice we don't have a checkbox property at all in the tree view item, because we don't need it. You can actually just compose the items yourself. And so if you want the checkbox on the right or the left, you can put it wherever you want now, because the content is a rich content model. Just drop it in. And we'll bind the checkbox to the isSelected property on our data layer. And then we'll take the inside the checkbox, we'll put again, the checkbox is a rich content control, and so we can put a panel inside the checkbox. And inside the checkbox, we can put two other controls, control and text block, and actually we'll just bind that to name. And so as you see here, we have bindings defined, and these bindings are relative to something we call the data context. And so what we do is we bind our collection up, it generates these items, and every item kind of has a data context that's the individual data item. And so the bindings are relative to that individual data item. And then one thing you'll notice is, since it's a hierarchical data template, there's actually another property set, which is item source. This is actually what does the recursion. It says, when you generate a tree view item, actually set the item source property for me so the recursion happens and just kind of recurses down the tree. And the nice thing about this is when you click expand, we generate the UI, and that call happens. And so it's kind of generated on demand. There's a set of things I didn't set initially using triggers. And actually, let's comment those out now and rerun the app. So I talked about this notion of making stuff dynamic in WPF. One thing I can do is I can trigger off this isDrive property and say, let's actually change the template for one of these controls to the drive template. So it actually looks like a drive when the isDrive property is true. Okay? Let's do some other triggers and say, when the child selection of my item is sum, let's go find the checkbox property. Right, I have a checkbox in here. And let's change the font style to italic. And likewise, when the selection is all, let's change the font weight to bold. Okay? With me so far? And if you actually look at the UI we have a tree view and a list box. Tree view we're binding to the drives property. We have another list box that's just binding to the selected directories property. So if you look at this XAML here, there's actually no reference to the data layer. And the data layer never touches any element on the screen. And so if my designer wanted to say, let's change the icon a different way, let's change the font a different way, let's actually spin the list checkbox around if you select the thing, whatever you want to do. It's now completely designable via XAML, via tools. And the data layer has no knowledge of it, which is actually really nice. As a developer, you build your business object. Actually, the really cool thing is, as a developer, you build your business object, build it in such a way that a designer can do no damage. You have your contract, design it so you can do no damage, and give it to him. And say, have fun with your business object. And this becomes a firewall now, right? As soon as you have a project where you have things talking between, the designer's opening the XAML file that talks to the CS file, oh no, he has actually direct access to the code, and that gets scary. So you make that firewall, actually, you get some nice isolation. So let's actually stop the app and rerun it now that these triggers are active. We'll go back to the folder picker. And now you notice that I have a drive, and the drive shows up with the right icon. The trigger worked. If I come in here and select something, immediately you see kind of the properties propagate. Identify property change happens with that selected children property, and we get the style changing. And so as I select things, the UI changes. So this is a very simple example. But again, this idea of define separation, define your behavior and markup, make a firewall between designer and developer, a really powerful concept. The other thing I wanted to talk about is another sample I had. So I get a lot of requests for paging support in our controls. They want the ability to say, I don't want to scroll through 100 items. I just want to show page 1 of 20, page 2 of 20, page 3 of 20, right? And so I could build that into a control. And what I pondered is, actually, it's kind of a data layer thing, right? Why can't I just build a class that takes the collection as an input, has some properties that say page size, for instance, and what page you're looking at, and then it outputs another collection as a property that's basically, the paging over the first collection. Make sense? And so I can imagine exposing a property for current page and page size. We can actually go even a step further with WPF and say, let's actually expose a set of commands. And so actually expose a command, the first command, and say, go to the first item. And the last command, go to the last item. And then next and previous. And these are just exposed as properties on this data object. Even crazier, I can actually expose out a collection of commands. And that collection of commands can actually have a command for page 1, page 2, page 3, page 4, generically, right? So if we go to list pager, we'll see that I have bound here. The source collection has an item count of 100. You see it up here. And I'm showing 20 items. Well, since size is this settable, gettable property, I can actually walk and say, let's change the size to actually fit the screen. And so right at 34. And so you'll notice a few things happening here. As I scroll around, we have a set of buttons here that's changing. This is actually a set of commands, UI buttons bound to those commands on the data object. And so as I click on 5, I go to page 5, 2, back to page 2. If I click on last page, I go to last page. And you'll notice that 6 disables, and next disables, and last disables. Because again, iCommand has this interface for are you enabled or not. And so even the notion of the UI turning on and off is completely subsumed by the iCommand. And so all that checking you do to say, like, are you actually on the last page? And if you are, okay, I need to go find all those buttons and set all those buttons and disable them, right? Because it makes no sense. Command just takes care of it. So again, this XAML here, there's no touching back to the code, right? The code doesn't touch any UI elements. Just a data layer. And actually this is a repeat button, so you can fly through the code really easily. As I change the current page size, I change the collection's bound, identify property change, the commands change. And so this is kind of an interesting example. But again, the flexibility of binding or list binding or commanding infrastructure to build a widget that's not even a UI widget that actually allows a lot of flexibility. And we'll show some more of this a little bit later. So that all kind of makes sense? Sound good? Interesting? Cool? So really 3 things: single binding, list binding, and commanding. Even at this layer, as a developer, think about this a lot. The less you can go and touch code, if you build your data layers cleverly, even if you're wearing both hats as a developer and designer, you can actually make things much less fragile in your system and give the person doing design a lot more flexibility. Okay? Next, let's talk about this idea of developer as widget author. And this idea that you can't do that in XAML, at least without me as a developer. So actually, those that went to Rob's talk already saw a great example of this, right? And that was the hand-drawn shapes. That's an excellent example of a widget. This idea that, I can imagine a designer in a certain scenario saying, oh, like, I want this to look really organic. Let me actually, take some strokes and do it in the design tool and import the stroke and kind of align it so it looks like a border. Like, you can imagine doing that. And after he did it for about the 3rd item, he was drawing lines around, trying to make them look organic and interesting. He'd probably go crazy, right? And so the idea is write the code. It might take more work than writing that first line, to make it organic and look good. But once you have that widget, it's infinitely reusable. It's reusable by the tool, and the designer can save all the time. And so that's kind of the idea of this idea of developer as widget. And so when you think about writing a widget, I kind of have these 3 models I want to talk about. First is the property system, how you plug into our system. Templates, kind of, how you pimp your control. And this notion of building these little widgets. So let's talk about the property system. So already we've seen all these examples, right, of doing styling and doing resources and doing binding and doing animation in WPF. What enables all of those things? It's actually this stuff: dependency object, dependency property. And so if you look at kind of our controls, or if you build your own control, we'll show a color picker here in a bit, they all derive from control, framework element, and as you kind of walk up the stack in Reflector, you get to DO. So what are the services that DO offers to a control author? Well, let's actually step back a second and say, how do you usually implement a property in, most apps? And it's like this, right? You have your publics, getter, setter, and you party against a field. And you might do a bunch of work to make sure, okay, let's not actually change the field unless the field's really changed. Let's go update some UI. Let's make sure we notify our property change. You will do all that work. So deep breath. This might scare a few people. This is DP. So the most important thing to realize here is the first bit. in terms of the public OM, what's exposed, we have public property with a getter and a setter. Now, how actually implemented internally, what the get and set actually do, and if as a user of control, you don't need to worry about. Just a public getter and setter, like you're always used to. Now, if you read through this code, it actually makes sense. It's like, okay, what's the name of the property in the registration? Color, what's the type of the property? You know, it's a type color. The owner type is color picker, because actually you need to tell the system what type owns this property. You actually set the default value. You can say, give me callbacks when the property changes. And so by doing that chunk of work, our system now, our property system, understands this property and lets you do really cool things with that property. What are those cool things? There's actually 7 tricks that DP lets you do. So at the very top, centralized storage, which is actually a cool part. Like, how often do people set min width on button, right? Like, never. The problem with that is somewhere you have a field that stores min width, and that field gets instantiated and lives as part of that object for its whole lifetime. Now, if you never set it, why not just go back to the type and ask the type to say, give me your default value, since it's never set? And so the fact we can do some efficiency with the default storage. We can support invalidation and actually a model for actually figuring out if a valid value exists for that type, even without setting it, which is really powerful. We enable binding, which, as we've seen, is really powerful, and we'll do some more. And attach properties. If you've seen the panel model, we do canvas.left, canvas.top. If you look at WinForms, right, every control has a top and a left, and an anchor property. That might not make sense for every panel. And so now that we have this attached property model, you can build your own panels and plug in your own system using attached properties. Certainly, animation is a really important thing. We'll actually handle animating things. And widths and heights, any doubles, we actually have animations for colors. And so if you have a very subtle transition of a color, you can actually animate a color property. We support that because it's DPs. And then this notion of supporting styles and triggers, which are very important for control customization, and inheritance. I can set a property at the top, at the window, and say, let's say the font style is Arial or something. And all the controls will inherit it because DP supports inheritance. And so the biggest thing to tell you here is if you build your own, well, 2 things. If you use components, you don't really need to think about this. It just kind of comes along for free. If you build components, if you build widgets, use DPs. I think in our whole framework of WPF and the whole thing, there might be 3 or 4 properties that aren't DP. Like every property is a DP. Every property is a dependency property. So really, the default should be, why wouldn't I make it a DP? DP should be default if you're building a control. Make sense? Sound good? All right. So this notion of templating, pimp my control. We talked already about data templates, right? And the ability to make a customized visualization for a piece of data. Let's actually extend that a bit further to talk about how you customize a control. And so if you look at the vast majority of controls in WPF, they all inherit from this control class. Now, there's certainly some things, our decorators, our panels, that inherit from framework element. But the vast majority of things you think about control, button, inherit from control. So what does control provide that's so special? Actually, really one property. Some other properties that are kind of helpers, but template is the magic. What is template? Well, the first thing to realize is template is just another property. It's just like background, just like font. You can set it directly in XAML. You can set it via style. It's just another property. But it's a special kind of property, because it actually allows you to define a whole UI, a whole visual tree for your control. And so when you think about building a control, instead of what people usually do, like a user control model, where you just define controls and define some code, what you do is actually define properties and maybe commands in your control. You define a template for your control that includes other UI elements, maybe sliders, for instance. And then you use binding to bind between the implementation of your control and the UI. And it actually works very simply kind of as a data template. And this is actually a good point to mention. This is something I see a lot of people stumble on, which is, when do I use data template versus control template? Because they seem kind of similar. Basically, think about what's the ether you're dealing with. If you're building a template where you're binding against things that are on the control, properties on the control, you're building a control template. If you're building a template that's binding against things in the data layer, like customer name, you're building a data template. And there's ways you actually can you could refer to data item properties for your control template and vice versa, because we have a very flexible binding system. So in general, kind of think about that, right? Control template, you're binding against control properties. Data template, you're binding against data properties. So let's actually look at a couple demos of controls and template. Let's close a few of these. And let's open up some code. So actually, the bag of tricks, I have 2 assemblies, a library and an app. In the library, I have all the controls. And so let's look at color picker. So the first, 2 things. First, you'll notice that I have just property definitions. And so I have, my public color, defined, red, green, blue defined, dependency properties for all of those. The other thing is, and I'll scroll very slowly, just keep me honest. One thing, oh, and I have an event to kind of notify when the color changes. You'll notice there's zero code here for rendering. And actually, people have asked this. Like, I want to look at code, and they use reflector. You know, I'm not going to say you should do it against our code, but they use reflector to go look. It's like, where's on render? Where's on paint? It doesn't exist, because this whole control is defined in XAML. So actually, let's go look at the color picker. And color picker's right here. So there's the template for color picker. And let's ignore the box in the bottom. So we'll see we have 3 labels, 3 sliders, 3 text blocks, and a big rectangle. If we actually go and look, actually stopping it will make things a little bit easier. So in the control library, actually, we have themes. And in the theme directory, we can go look. There's generic.xaml. And so if you're building your own library of controls, generic basically says this is the fallback. And so actually, you can name things for specific themes. For instance, I have a Luna version of some controls. But generic's the fallback. So by default, you should use generic.xaml. And in here, I have a merge dictionary, and I actually bring in my color picker XAML file. So let's go look at color picker. And so I have some resources I define, some converters, and then I have a style that sets some properties. So I'm setting, alignment properties, and then I set the template property, just setting another template. And inside this, just a set of controls, right? So I have a grid. I define some rows. I have labels, red, green, blue, the target elements, just how you always use a label in a window. And then I have sliders. And so I define a style for slider that I can reuse. And I said the value is a binding. And here I'm binding to blue, green, and where's the other one? Red. I do some other work here using a converter to convert between the double produced by a slider and the byte that's taken by the color picker. And so, again, declaratively, you can actually use code and instantiate code to do the conversion. And so I have 3 sliders that show those things. I have 3 text boxes that show those things. And so I have bindings to red, green, and blue. And then I actually have a rectangle that's bound to the color property. And so you notice as I change the slider, the value changes. I can actually come in here and type in a value. Oops, a little bit too big. All those old web heads, I'll give a shout out to all the old web heads that had to worry about the default palette, right? Remember that? Remember those days? So color picker didn't say you had to use sliders. It didn't say you could use text boxes. You could use either. You can pull the text boxes out, just use sliders. The second one actually is interesting. Looks completely different, right? It looks similar. It looks familiar, right? I have sliders here. This is actually a couple demos. First is I'm just binding between the two. And I'm binding between 2 elements and showing how you can bind 2 things. And second is, this is the exact same control. Exact same control with a customized template. And actually, if we open up in Blend, we can look at the template. Let me close it down. And so I have my project open up here in Blend. I can actually walk into my color picker app. There are my controls. F4 is a great key. And so here is this control. Control 0 to zoom in. Actually, let's do this. Control 0 again. So if you look at the UI here, there's my color picker. Let's actually go edit the template for this color picker. And so I can right-click and Blend and go Edit Template. And now we're editing the tree that represents the custom template for the color picker. And again, in here, we have a set of borders, we have a grid, and then exactly what you saw before, 3 sliders and 2 borders. So my first template had a slider, and this template has a slider. This slider looks a lot different, right? Well, slider in WPF is a control, and controls have templates, and you can add those templates. And so what I did is actually I composed sliders and then edited the template for those sliders. So let's walk into this slider and see what the template looks like. And so now we're editing the template for the slider. And so again, I have a border and a track in there. So actually, the border, I can come into properties here, and let's do corner radius, and let's change that to be 3. So it'll kind of round out the edges of my sliders. And let's drill in. So we have a track in here. Inside the track, we have a thumb. The thumb itself is a control. The control has a template. So let's drill in yet another level to the control template for the thumb. And so now we're editing the control template for the thumb. And inside the thumb, there are 3 rectangles. And let's come here and go to, let's see, is radius? Yeah. And let's change the radius for my thumb. Now what you'll notice is I'm editing the template for the thumb that the slider uses. All the sliders use the exact same template. So actually, if I zoom out, oops, let's do this. Yeah, this will be better. There we go. You'll notice that all the templates for all the sliders changed. And so if we save this, and just to keep us completely sane, we'll go back to VS and run. Now we have slightly more funky sliders and rounded edges. So a couple examples. You define your control, your template independently from the code, which gives flexibility. This flexibility allows you to do this kind of composition. Now the power is, since our existing controls also have templates, you can template those controls as well. So this is just the slider you always used, right? And if a dev is using that slider, the slider looks and acts, has the same events, properties as every other slider. But you can have a very customized experience. The other example I'm going to show quickly is a control we call info text box. So people have probably seen on the Vista login screen or on web pages this concept of you have a text box, and then inside of it you put a piece of text to say what it is, right? So instead of having a label, you say like password inside the password box. And in HTML, it's always kludgy, right? When you double click on it, sometimes you select the password, and there's crazy event handlers to handle that. So what I thought would be cool is to take an existing text box, this editing control, and actually add the ability to have this label overlaid on it. And so I'm just subclassing the existing text box here. And what I do, I just add some properties. And so I add the string text box info, which is basically the string we want to display. And I add another property, which is has text, a Boolean. And the reason I do this is the existing text property, you want your thing to fade away, right? Your info to fade away when someone types something in. Has text is easy to bind to. Because if you bind to that string, the string doesn't give you events to say, length is now 0 or something, right? And so this is just a convenience property I added to the template, or to the control, so the template author can have an easier time. And so this is, again, something you think of as a developer, right? What widgets do I add to my control so that's easy to template? And people that do design in here should think about that as well. When you're building a template for a control, you're like, oh, I know there's some state here that it's tough to get to, or I can't get to at all. And you go to your developer and it's like, please give me a property I can bind to. And then the template can light up. And so let's go to info text box, and first name, last name. And so you notice when I enter the control, the text fades out. When I start typing, it fades out further, right? The code for this looks almost exactly like the stuff we showed in the data layer. We have a control template. Inside that, we have a border, a grid. Inside the grid, we have this decorator. Now, this is an important thing to mention. A lot of our controls actually, there's a contract, and the control expects a certain thing. In the example of text block, it needs a thing to go render the text. The text is not just another control, right? It's a pretty complicated set of visuals and interaction. So basically, the contract says, if you template text box, give it a part, and name it that way so the control can go find that thing. So there's one spot where you kind of have this blur across, and the template needs to know about the code and vice versa. This is pretty rare, but you should be aware of it for certain controls. And you can do this for your controls if you need to. Try to avoid it, though. Try to keep it binding if you can. Then all I do is add a text block on top of this. I said, is head test visible? It goes false, so you don't hit test the thing. And I do italic, and I set the opacity, and I set some alignment properties. Now, I showed this demo before to somebody, and they're like, well, why would I ever want to do templates for this? Where did she go? I could write that all in code, right? Well, the reason is, now that it's all defined via templates, you can change the triggers. And so you notice I have a multi-trigger here. It says when has text is false and is focused true, run some animations to actually fade the text out a little bit. And then when it actually has text, fade everything out to no opacity. And there's the simple storyboards defined there. You could do even cooler things. You could do a render transform and say, when it has text, have the text fly out towards the user and fade away. Or when they start typing, have the text scoot over to the right. You can do whatever you want. So now that it's defined in a template, a designer can party over those things and make a custom experience for this control. Make sense? Sound good? OK. And so this is actually a very simple topic. And this notion of building a widget, a useful widget. let's start with tree view. And we showed tree view with our folder picker, right? So what is tree view? Well, actually, that's a complicated question. If you look in terms of object inheritance, it inherits from items control, right? So it inherits all that ability to generate visuals, which is really nice. If you look at the template for tree view, at least the default template, it uses a scroll viewer, okay? Now, scroll viewer is a content control, holds content, but actually has Chrome to allow scrolling through that content. So if you crack open the template for the default scroll viewer, what do you have? It uses a scroll bar, okay? Now, scroll bar is a range base, just like sliders are range base. So again, this use of inheritance. Now, if we crack the template for scroll bar, you see scroll bar uses a track. Now, track is a framework element. Actually, it custom composes visuals itself using code. We'll talk a little bit about how that does later. But it can compose existing controls. And so actually, the code inside track instantiates visuals. And one of those visuals is a thumb. And that thumb is a control, which means it has a template. And so if you look at this use of subclassing and templating, it's this layering, right, and this composition. And this gives you a lot of flexibility, not only in building your own controls, but customizing our existing controls. So let's use a very simple example of this expanding decorator. So my good buddy Ben worked on this. Although, of course, I call it reveal in here. He didn't like expanding decorators. Like, let's call it reveal. It's like, all right, naming. So what we have here is 4 expanding decorators. Actually, it looks like 2 lines and 2 dots. But if you, click on the expand, you'll see that they kind of expand to show some content. So these are decorators, right? Just like border's a decorator and viewbox is a decorator. And there's some content here, and you notice there's some properties on reveal so that when you set is expanded, it expand down, expand up, expand from the corner. Interesting little widget, right? I can imagine maybe using it a few places in WPF. You'll notice that it sizes the content really nicely. Pretty cool. The other thing is it has a property. A bool is expanded property, which allows binding, right? You can imagine having 2 methods, expand, collapse, but those aren't available declaratively, right? So you use a property so that can be accessed declaratively. So why is that interesting? Well, you can take a control like our tree view. That inside its template right now, when you do expand, collapse, it just changes the visibility of the children. Now I can change tree view so that when I expand, collapse, it actually animates. So I've customized the existing template in tree view to use my custom little widget, and now I have a cool behavior in the existing control. Moreover, there's this expander control that exists in the platform. I can change the template of expander, so instead of doing the reveal using collapse expand, I can do the animation. And so this goes back to Rob's example of the hand-drawn shapes. Think about this a lot. Like if your designer is going crazy or doing a lot of things over, like what's the right little widget I can build to add a lot of flexibility or customization? And if you kind of think in this model and build things in this model, you can build a whole kind of your own little bag of tricks, right? That lets you do really cool things, give your designer a lot more flexibility. And designers, 2 things. One is you'll notice you're doing things a lot over and doing things over a lot and running into a lot of trouble or just repeating yourself. It's kind of the Ruby on Rails thing, dry, don't repeat yourself. Go to your designer, like, I need a widget that does this. And help him make sure that the behavior of that widget is good, right? Because as soon as he starts writing code, it's like the code behind thing or the on-render thing. He might mess it up. So yell at him, make sure he makes it look cool and the animation's smooth. But if you build the right widget, you can have this kind of experience, right? So think in terms of widgets. So there's 3 things, right? If you build components, use a property system, plug in, dependency property. And if you're just using controls, you don't have to think about it. It just happens for you, right? Public setter, public getter, it's a property. If you build a component, think about using templates, because it gives you a lot of power and flexibility. We showed that in Color Picker with a completely new control. We showed that with Info Text Box, subclassing an existing control. And then think in terms of widgets. Like, if someone's repeating themselves a lot, it's a set of functionality you can't use. If you build the right thing and use the right subclass, you actually can not only use it in your own custom components, but you can restyle our existing controls to have cool behavior. And actually, we'll show an example of some really advanced widgets here in a second. Developer is groundbreaker. So the last subtitle was, you can't do that in XAML without me. Now this is this notion that you really can't do that in XAML. And this goes back to kind of the set of things I discussed in my opening slide, which is, as a developer, because we're a managed system, you have access to the plumbing. And you can instantiate visuals and deal with things directly, move things around the screen. It's all CLR types. And so the flexibility you have as a developer transcends that of a designer. So let's talk about a little bit. Actually, I don't have any bolts here. I just have this fun little thing. So there's a bunch of ways you can do this, but I want to talk about one trick I use a lot and have a lot of fun with. And this is kind of playing with this notion of making really interactive and organic interaction in your controls. And so we have an animation system in WPF, and that animation system is really flexible. It lets you, animate from point A to point B. You can do, you can define keyframes to have smooth animation. You can accelerate in, accelerate out, all those fun things. But there's a whole set of stuff where you want really custom behavior and really organic behavior. And so nothing can touch the flexibility of code to do that. And so, let's put on our high school physics hats. Force equals mass times acceleration, right? So basically, force is proportionate to acceleration. And so what you want to do is, if you calculate some forces, basically you're calculating the acceleration with some, constant, right? And so what's a force? It's a push or a pull. So the idea is, if I want two objects to come together, you can think about what's the force here? Well, I can take point where this object is and point where this object is. If you subtract the two, actually we have a point class in WPF, you get a vector. And the vector is the distance between. And it actually has x and y. Even cooler, we have point 3D and vector 3D. And so if you have things in 3 space and do the subtracting, you get a vector 3D when you subtract 2 points. And so now you can say, OK, I have a force that's proportionate to the distance apart from those two things, right? And so if you want an attraction, that's kind of how you do things. To get realistic behavior, not only do you want to remember where your object is, but remember what its current velocity is every time you do a tick. Every time you kind of think about, you want to recalculate your physics model. Because that actually gives you this feeling of physics. Like it might already be in the position you want it to be, but maybe it's flying from the bottom corner, and so it actually bounces up a little bit and settles down, right? So not only, you have to remember the per item location, also remember the per item velocity. And all you do is you say, the current velocity, the next velocity, kind of every tick, take the current velocity, and take it, some constant times the force. The force is that delta, right? You calculated. And change the stored velocity. The second notion is dampening, and that's how you get your system to settle, right? If you don't do any dampening, the velocities always add up and it bounces around forever. So basically every tick, you just kind of slow things down a little bit and things settle down. And the cool thing is you can mess with dampening to give really kind of dynamic experiences. And I'll show you a demo here in a second. And the third thing is give it a terminal velocity. There's sometimes you get weird rounding errors or things fly off really far away. You don't necessarily want them to come zipping across the screen and the user doesn't see. And so you can imagine implementing a limit function that makes sure you maintain is a negative or positive, but constrain it to some maximum velocity. And then you update your position as some delta times your velocity. And so there's actually a couple tricks used in the bag of tricks. The most common one I do to do this is this thing called compositionTarget.render. And actually, you get a tick every time the frame ticks, every time we render a frame. And you can get that tick and keep track of how much time has passed if you want to. You don't necessarily have to. It looks fine without it. And you get that tick, and you run this calculation against all your objects. The other fun thing is either in, when you apply the force or the dampening, derive a random number for every element. Like some, between 0.95 and 1.05. Define a random number. And then use that for that object throughout your system. That gives a little randomness. So if you have a bunch of things flying around, they actually kind of all settle at slightly different times. And again, it makes it look that much more organic and less kind of robotic. So actually, I have a whole set of tricks here to talk through this model. Let's close down some stuff we don't need. And rebuild the project. Again, this is all available when we get done here today. Control F5 in a release build. Again, will fly without a net. Not that I would torture you guys by trying to debug physics on stage. So what's the first one I want to show? Let's show, so we did list pager. Where did list pager go? This idea of binding to kind of like the current page, right? And so it's this idea that I have a UI bound to the pages, in a page data set. I'm really bad with naming too, so I call this thing Zap Scroller. Zap Scroller actually inherits from items control. So again, I'm using items control, all the things you do to think about items control and item generation. Inside items control, I built a bunch of custom elements. And so here I just give it a bunch of text. I was trying to think of text that's kind of a set of numbered things that's in the public domain, and obviously the Bill of Rights is as good as any. And so what you do is when you click, you actually scroll across. And you notice, it kind of settles in a nice way. So this is the default template of this control. Now the cool thing is it uses all that stuff I talked about before, right? Data binding, data templates, the fact that our content model can support anything. So this is the default template, pretty simple. I can actually change the template of this, and this element here is actually part of the template of the control, and I'm binding to commands defined in these elements in my control. So if we go to colors, well, first of all, arbitrary content, right? So I actually put brushes in here and then bind and show both the string that represents the color and the color itself. This is even more fun. Since the top element is also part of the template and I can template it, not only do I expose commands in that data object, I actually expose the data item itself it's referring to. And so not only can I bind to the command, I can bind to the data item and show previews. And since, again, this collection up here is an items control, I can use control templates on all those items. And so when I do mouse over, this is just XAML tricks to change the mouse over effect. And then when I click, I can scroll to that image. And then again, I have the same trick with, this is, of all the stuff, I don't, template the buttons, but you could have templated the button, right? And so this is a repeat button, so as I hold down, I can scroll through the images. So again, this idea that, in terms of how you think about it as a developer, items control, use list binding, exactly the same. You build the right widgets, and now your designer can have the flexibility to build this kind of experience. Cool? All right. So Rob talked about panels and the flexibility of our panel model. And one of the panels we ship is wrap panel. And so this idea that I can put items in, and it wraps left to right, top to bottom. So panel is a framework element. Panel doesn't have a template. But you can plug into our layout system. Rob, again, talked about our layout system and how you plug in. Well, let's apply some of those physics ideas to this layout system. So if I change the size of the items inside my panel, I change the size of the panel itself, you want to reflow. By default, what you do is you recalculate where everything goes in that reflow, and you set it to be where you want it at that moment. What I do here is actually say, instead of actually moving you where I want you, I'll set a property that says, this is where you should be. And then my physics model will tick every frame and move you. And so as I resize the window, and you notice it looks very organic. If I change the attraction factor to be something insane, they pop together much more fast. You can change the size of items. And the fun thing here, actually, you change the size of items. So now, they're stacked down, to the basement. And so if I change the size back, they'll come flying up from the basement. So we need sound support. And you can mess with dampening. So I drop that dampening down a lot. And so things get really sluggish, right? And it's a much more controlled experience, right? You can get even crazier and make it just barely one. And now when you move things, everything's, crazy. And so obviously you wouldn't give your users those knobs. But again, as a control author, as a component author, one is we're using panel. And because we're using panel, I can now use this panel in a list box. I can data bind that list box, and now data bound items get this behavior, right, because you use panel. The second thing is, since I actually expose the properties that represent the physics model, the designer can now tweak the behavior so that for the scenario you're doing, maybe it's a kid's app, you want it to bounce around like crazy. Maybe it's a very professional app, you want a very smooth transition. You can tweak that now using Blend. OK? This is a cheat sheet. I'm going to remember actually what I was. Transition control. Oh, that's fun. So let's go to a different app. So ignore the thing on the left. Here we have some UI, right? Some controls. And I can click and, drag and change, tab control. Oops. And I have some images and some colors. So this is just a list box up here, just a list box. And this element before, let's pretend now it's a content control, right? And you can bind a content control to the selected item on the list box. And so when I change the list box, I change what's in the content control. Now that's kind of boring, right? It just swaps it in place. This is where we get into this notion of widget and building the right kind of widget. You can imagine creating a widget that looks a lot like a content control or content presenter. It has a content property, accepts data or UI, controls or data. But when the content changes, you want to affect that when the content changes. And you want to modify that visual tree, right? That behavior, that support we have in WPF. And so let's do a fade. So when I change, let's do opacity, right? Maybe do a fade wipe. And so when I change that, you get more of an organic wipe. Let's do a rotate. Like Spielberg effect. Let's do blinds. Let's actually change the render transform and the opacity at the same time. Okay, a deep breath. Now we can have more fun. Let's do, okay, translate's pretty easy. Let's do a, oh Lord, I always forget which one's a cool one. There we go. I don't know where I've ever seen this before. I thought it was a cool transition. I swear, completely original. So now we're leveraging 3D, right? Let's go even crazier and say, all right, how about like the shotgun effect? So when I click on the image. Oh, and like, does it work to UI? Yes. And the UI, is still interactive. Switch back. Guess what? So 2 things. In terms of the developer and how, even a designer, how the designer thinks about using this control, the difference between this experience and this experience is the same. In terms of how the control behaves, identical. It's a pluggable behavior. Now there's some other cool stuff with this. Oh, and actually the last one. Turn the page. Oops. Oh, this might be it for back button. Where was I? It was transition, right? This is when it would blow up. I was doing so well. I hit the wrong key. I know I should have removed the crash key. What was I thinking? I thought it'd be useful. There we go. So I want to actually show the code for this real quick. So there's all these transitions. There's a base class transition that you plug. There's actually a defined, Niels, a developer on our team, did this great work. He actually defined a storyboard transition. And again, this is just a class you define. If you go and look at actually how you use transition element in the app, let's actually load this here. You'll see I defined an array of transitions. And I load a bunch of different transitions in here. Since they're defined the right way, transitions can be defined in XAML. They're just CLR classes, right? XAML just instantiates CLR classes. You'll notice that there's a storyboard transition. There's actually a way. So Neil built this correctly, built this in the right way, so that whole sets of these transitions can be defined in XAML. And so what you do is you kind of set up an initial storyboard that you want to animate, and then you say, what's the new content storyboard and the old content storyboard, or the old content. You define a style that instantiates kind of, the effects you want in the tree, and then define storyboards to animate those. And so now actually someone in XAML can go in and say, oh, instead of flying in from the bottom, I'm going to fly in from the left, and modify it via XAML. Now, obviously, Blend won't have design time support for this, but if he understands the model, it's pretty easy. And again, these things can all be instantiated in XAML. To the point, if you actually look at this is actually content control bound to 2 collections. One is the content collection bound to the top, and the second is to the transition collection that changes the behavior. So again, just data binding to an array, to a collection. Oh, I'm right on time. Good. So Brian Wheeler, is Brian in here? Hi, Brian. Brian was playing with my tile panel for his newsreader stuff. And he's putting pictures in it and having fun. And he's like, Kevin, I'm using this image, this tile panel, and I like it. I want to do a cool view on images. And so I was like, well, that tile panel's kind of fun for that. And then I thought, well, I have this demo coming up, and I'm talking about code. And I had this crazy idea in my head of a demo I could do with pictures. And so I'd never done 3D at all in WPF. I have too much fun with 2D. But I kind of went home on a Friday night, and I started hacking. And I learned all this insane stuff about 3D, like, positive Y is down on 2D, right? Most 2D platforms. Positive Y is up in 3D, and so you get your head around that and think about it. And then, rotation in 3D is done in quatrions, these crazy data structures, and I'd get my head around that, and texture coordinates. But I realized for a whole set of stuff, it's like hit testing, I can handle that. Bringing in resources, bringing in brushes, loading images, I understand those concepts. And so let's do a cool visualization on pictures. And actually, even crazier, I can have to oops, I can't do that quite yet. So I built this. Let's actually full screen it here. So this is just a set of images I load off, and I have a cool 3D animation kind of flying in. Well, I have all these physics tricks, right? And so what happens if I mouse over an image? They all kind of turn to face. And so I'm just using 2D hit testing here on the UI element, and then I know my positioning of my tiles, and I tell them how to tip. And again, the tip is done with this physics model. And so you notice like the item, when I mouse away, it kind of bounces back and then bounces forward. Again, like I'm just doing my animations, my little tricks, to a bunch of stuff. To XYZ position, to scale, to rotation. Animating rotation with quatrions, like, good luck, get on Wikipedia, it's tough. Like, I'm not going to offer much help there. I'm surprised this actually works here. So we're looking at tiles. So what happens when I click on a tile, right? Well, let's do a navigation to another window and show the image. Let's click and actually have the tile zoom up to look at the tile. Oh, that's not cool. Let's actually choose textures, and when I click, show the image. So again, you can imagine in XAML doing a couple images and doing animation and a trigger to flip, but having this kind of interactivity, you just can't do in XAML. But again, the platform is powerful enough with 3D, with textures, with our data binding model. Like all I do here is in this tick, I just change all these properties, and the system just updates for me. And actually, Rob found a cool feature that I just do hit test, and so as you move around, you can look at different images. So, oh Lord, one last gratuitous use of Flip 3D. So 3 things to think about as a developer in WPF. One is, be a good plumber, because you have a good separation between your UI and your code. It'll be less fragile. You can just kind of enable the designer, right? The designer says, hey, I need something to trigger off this property, make it, I know if a property change, implement it. And don't, avoid the hit testing, the on-click, like use commanding. Now again, there'll be times you use it. Like, don't be silly. I've seen people, like, you can spend 10 minutes writing command implementation, or it takes 30 seconds to do the click. Like, be smart. But if this is something where you have a data layer, and you're going to use it a lot, and use it all over, and you want menu and 2 buttons bound to that, maybe you want to use a command instead of having 3 click handlers, right? So, all things in moderation. Widget author. We talked about, building the right kind of controls, using the property system. If you use control, you have flexible templates, so the color picker can look that cool. And build the right widgets. Use things like the reveal control. Like the right little decorator can do a lot of cool things. The hand-drawn shapes are much easier than having to redraw that every time. And then finally, it's Groundbreaker. There's a set of stuff you just can't do in XAML. And because, whether it's a physics model that you're playing with, or custom components, we give you a lot of depth in WPF. Don't feel like you're restricted by what markup does. And if you're really smart, like I showed in transition control, you build things correctly. Not only do you build a groundbreaking experience, but you make it very accessible via XAML and tools if you build it correctly. So don't forget, XAML plus code is love. And that's all I have. And as promised, this is only available for those, where are you? Come on here. Only available for those who fill out an evaluation. CSA, fill out your evaluation. The link to the bag of tricks is now on the blog. And so all the stuff I showed. And I am available for 9 minutes for questions, and then certainly we'll be in the lounge afterwards to chat. And the microphones are set up.